Hi everyone, let's take a deep dive into the history of semiconductor and see how they shaped the technology that we use today. So let's start at the very beginning. So it all started in 1904 when electronics was dependent on vacuum tubes. They were large, fragile, generated a lot of heat, and consumed huge amounts of power. But at that time, they were the only way to control electrical signals. So, as technology needs grew, it became clear that something smaller, faster, and more efficient was needed. That breakthrough came on December 23, 1947, at Bell Laboratories in New Jersey, when the world saw its first working transistor. So, invented by John Burdeen, Walter Bretton, and William Shockley, the transistor replaced bulky vacuum tubes with a tiny solid state device that used far less power. So, this moment is considered as one of the most important inventions in human history. Soon after, in 1948, Shockley introduced the bipolar junction transistor, a more reliable design that entered mass production in the early 1950s. So, this marked the beginning of widespread transistor use in radios, computers, and electronic systems. Okay, after that, the next revolutionary step came between 1955 and 1960s, again at Bell Labs, with the invention of MOSFET, that is metal oxide semiconductor field effect transistor. So by using silicon dioxide for surface passivation, scientists created planar transistor that could be densely packed on a single chip. So introduced in 1959, the MOSFET became the foundation of modern electronics. In fact, it is the most manufactured device in human history with over 36 trillion MOSFET produced by 2018. So we can see how this way transistors evolved throughout the year. So this laid the foundation of for the digital world that we live in. So next, after the 1960s, the semiconductor entered. You can see the completely new era. This is when technology nodes, the smallest feature on a chip, started shaping the pace of innovation. So early nodes were measured in microns, but as engineers pushed the boundaries, we moved into the nanometer scale, which was like 7 nanometer, 5 nanometer, and now even 3 nanometer chips power modern devices. So to keep Moore's law alive, engineers invented clear new techniques like EUV lithography, which allowed them to etch incredibly fine patterns on silicon wafer, making advanced shapes possible. Okay, here you can see uh, the how it evolved after 2000. Okay, so when thinking sideways became too hard, they started thinking vertically, like 3D stacking. So which allows them to multiple layers of circuit to sit on top of each other. This way, improving the performance in the same footprint. At the time, new materials like graphene and carbon nanotubes, along with innovative transistor designs such as GOFET and nanosheet transistors, helped reduce power leakage while boosting speed. So leading companies like TSMC, Samsung are now pushing towards 2 nanometer and even a smaller node, making chips faster, smarter, and more efficient. And yet the story is no longer just about shrinking transistors. Today, the focus is on a heterogeneous integration, combining different devices and technologies to optimize entire systems rather than individual components. So, this is the future of semiconductors: smaller, smarter, and more powerful than ever before. Next, we will see how this development of the FETs happened. So, initially, planar MOSFET were used, where the gate controlled the channel from only one side. As dimensions shrank, short channel effects increased, limiting their use beyond 20 nanometer nodes. To overcome this, FinFETs were introduced by forming a vertical fin-shaped channel and placing the gate on three sides. Electrostatic control improved and leakage was reduced. However, as scaling continued, even FinFET reached their limits because the channel was not fully surrounded by the gate. So this led to the development of GAUFET, that is gate all-around transistor. So with the gate completely enclosing the channel, control was maximized. So now we are also moving towards multi-bridge transistors, and which is the further like improved version of GAUFET, which will allow us more efficiency and lower power and a smaller area it will be having. So these things will be used in the advanced nodes. Okay, next we will move towards, we will see the application of VLSI technology. So here you can see it is used everywhere, whether it is a consumer electronics, telecommunications, automotive industry, or healthcare. So we are utilizing VLSI in every domain of our life. So here you can see um, VLSI is everywhere. It powers from simple you can for let's say smartphones and smartwatches that we use every day, right? So it helps. It is also helping in like modern cars to drive safely with advanced systems and even self-driving features that they have. Then it keeps us connected through fast internet and 5G networks, and we are also using it in hospitals through medical imaging and wearable monitors and AI diagnostics. So we are using in different ways, like in smart homes, in in robotics also, and in cloud AI services. So this way it is making our life easier and faster. So basically every device that we see today has VLSI inside it, which is making everything work faster and smarter, right? And with the growth, and after that with the growth of AI and machine learning, chips are handling massive data efficiently, and the rise of IoT devices also makes the designs reliable. So overall VLSI will remain the key driver for innovation in next generation technologies. Okay. In summary, what I can say, VLSI technology powers today's electronics, and it will shape the future of AI, IoT, automotive, and high performance computing. So far we have talked about what VLSI is and where it is used and how it powers almost every modern technology around us, from smartphones and AI to automotive systems and high performance computing. So now the real question is, do you want to just learn about VLSI or do you want to build the future with it? So at Innosilica, we don't just design chips, we design impact. We work on real world semiconductor solutions that reach millions of users globally. So I would request to start your journey with Innosilica because that's exactly what we offer. A journey of growth, innovation, mentorship, and cutting edge engineering. So, if you are passionate about electronics, problem solving, and creating technologies that matters, then Innosilica is the place where your potential can truly shape. So we are looking for curious mind and people who are motivated for learning new things and and the engineers who are ready to take chase different challenges and this way they will grow with us, grow along with us, right? So if you're excited by what you have heard today, I warmly invite you to explore opportunities with Innosilica and take your first step towards a meaningful career in VLSI. As you can see, Innosilica is a technology-driven company that provides complete engineering solutions across multiple domains. First, we work extensively in semiconductor design, including ASIC and FPGA solution. Then this involves designing chips and hardware system that power modern electronics, right? So we also focus in embedded system and where both hardware and software come together, right? To deal with the real time products. Another key area is artificial intelligence and software engineering, which include machine learning as well to develop smart systems which can analyze like data and make decisions. In addition to that, like we also provide solutions in IoT, cloud computing, avionics, and automotive services, supporting different industries that demand high reliability and cutting edge technology. So, what makes Innosilica unique is that we don't just specialize in one area. We offer end-to-end engineering solutions, giving our engineers exposure to a wide range of technologies and real-world projects. So, here we can see we are into complete chip development life cycle, starting from the RTL and synthesis to final sign-off stage. So we are into each and every domain of VLSI. So if you that brings that brings me to the end of the presentation. So we have explored what VLSI is, its real-world applications, and how Innosilica delivers end-to-end semiconductor solutions. So if today's discussion sparked your interest in VLSI and inspired you to build a career in this exciting domain, I would love to connect with you. Please feel free to reach out on the contact details that is mentioned in the slide, or you can mail us, or please kindly go through the website that is www.innosilica.com. Thank you to everyone. Thank you for your time and patience. Thank you.